I think I'm going to introduce the panelists first. I think pretty much in the order that they were speaking this morning. We have Andres Olivares, clinical pharmacologist and DMPK leader at Roche. We have Ylva Terelius, CEO at ADMEYT AB in Sweden. Robert Fraczkiewicz, research fellow at Simulations Plus. Lisl Shoda, associate vice president and director of immunology at Simulations Plus. Thank you for joining us in this session. Deanna Mudie, senior principal engineer in research and development at Lonza. And we have Zack, Kenz, principal scientist at Simulations Plus, and Jeff Woodhead, senior principal scientist at Simulations Plus. Thank you for coming back for this session. So maybe we can seed, unless there are some specific topics, maybe we can seed some interest. Maybe what do you see as the most significant changes that are going on right now in terms of discovery or further downstream in your area? Do you see them within the technologies themselves, or do you see them at the interface of technologies? Like Andres this morning was talking to us about really bringing certain aspects of PBPK modeling that have mostly been done on the pharmaceutical development side, being done now in discovery stage at a very high throughput. So it makes these technologies now usable in a discovery setting, and that's again kind of front loading some of what was done previously downstream now in a discovery setting. So are we seeing more within silos, or are we seeing more in between silos, like pharmacogenomics or pharmacometrics, or sort of interface, in between sciences developing between areas? Anybody cares to share what they feel is the most significant, or what are the most significant changes that are going on in their particular space?
I can start, and I can say that I see more and more being done earlier, and also across disciplines, and also, of course, I mean, modeling is becoming more and more important, even for regulatory documents and applications. And I think it's starting to get accepted by authorities in most countries as well.
Okay, thank you. Any other panelists?
Sure. I would say that, again, that push toward earlier and earlier assessments, and really looking at the molecule structure, and even starting to make predictions about will bioavailability enhancement be required, is a really powerful tool, and I think can really change the way people begin the journey early on in terms of understanding if their drug-free form or salt form or ASD will be the best solid form moving forward.
Anybody else?
Yes, from my point of view, the biggest change will be illustrated by the screen that I'm about to share. Let me know if you see it.
Not yet, Robert.
I have shown this slide.
Yep. We see your slide.
Minutes ago. It illustrates the difference between the what I call the literature chemical space, or small organic chemicals that can be extracted from literature, this in the context of the pKa data, and the industrial space. Okay, the industrial meaning the pharmaceuticals and so on. In this case, pharmaceuticals, but we also received non-pharmaceutical compounds, so I can also see differences there. This is the reason why the so-called global models, which are trained on the public side in general, may not work at pharmaceutical companies, and this is why so-called local models built in-house, as also Ylva Terelius can attest, have better performance. So yes, this is a very good trend to use ADMEYT modeler to build the local models. A better method would be combining both, the model built in the public space and the local space. The ADMEYT modeler provides a mechanism called delta model. I will not dwell on that too much, but it's best of both, I would say. But the very best change that is now occurring. Okay? Now big pharma starts opening its silos. They are very secretive, very protective of their chemical structures, but essentially sharing data with us with the purpose of building a better model is the best approach. Yeah. And as I said, we had Bayer share data with us in 2012. For 10 years, nothing happened. And now, when it rains, it's pouring, right? We have partner 1, 2, and 3 at almost the same time, giving us data to improve the model. And they see big improvements. Everybody benefits. There is little risk in doing that, and a lot of good stuff happening because of that.
Yeah, thank you, Robert. Yeah, no, for sure. I mean, and again, even for those models that we think are already pretty advanced in terms of, I mean, us having trained these models on very large data sets already, when we think there is not that much more to learn, well, guess what? There is. Yeah, it's, and I mean, maybe comment also, I mean, I think if something is more feasible or easy to do, easy to deploy, I think our customers will be more likely to use these methodologies than if, I mean, we were commenting, I mean, Andres gave some great information on high throughput PK. It's also the deployability of the methodology that if, you're trying to do these simulations, and if it's going to take 10 days to do, you're going to kind of think twice about doing it and then looking at results. But if it's an overnight run, well, you're just going to do it and see what kind of results you can get. So I think there's just a lot more of it happening just because of the feasibility of the of these methodologies, probably.
Right.
And
so if I can chime in from the QSP space, because I think that we relatively speaking, we operate in a different space in terms of the availability of data and the number of compounds that are represented in particular models. And so, relative to some of the numbers that were put out by, number of compounds, thousands of compounds evaluated, it's a different space for QSP. And I would say that, in terms of sort of mechanistic understanding of disease pathophysiology and what have you, I think we do, a reasonable job of pulling in the available data for compounds where we have, an understanding of how, we have an understanding of exposure, of mechanism of action, and of clinical response, and to use those types of data in order to provide qualification for the model. That said, I think that there are many examples, and I would invite maybe Zack and Jeff to talk to this in their particular scenarios where, working either in a local area of the model with proprietary data to better understand, exactly what's represented, maybe even expand on what's represented to add more detail to better capture those mechanisms, and or reproducing clinical data that's already come out in preparation for those prospective simulations is really a mechanism by which the team gets engaged, right? Our collaborators are engaged and learn more about how these various mechanisms that they tend to look at in a local space fit into the general pathophysiology, and B, to drive increased confidence in prospective simulations.
Well, thank you, Lisl. Yeah. Jeff or Zack or any or Andres, any other perspective on the topic? Andrew, was there something you wanted to?
Can you hear me?
Yes. Yes.
Sorry. Apologize. I'm traveling right now, so I can't turn off the video without disconnecting.
No, that's fine.
But, I think what you were mentioning for us, you have this the so-called hype curve, right? Like when we have a new technology, there is a hype, and then there is a certain stage when we get to a certain mature state and we start deploying it. For us, PBPK, for instance, is something that at the beginning was seen as, let's say, more like an academic exercise. Now has been validated a lot in the industry, and we are using it for informing regulatory decisions. But still remains like a very dedicated craft. So in our case, we said how we can bring this to our pipeline, and the main obstacle is not the science, actually, is, as you said, the deployability. The fact, for instance, is there an API where we can connect a data set to A, or our data sources A to B? How can we implement this globally in our projects? How can everybody has access to it? So it's more like a scalability problem. And this is not a minor technical challenge. I would say at the beginning, it was very difficult for us to get this done. We had to use a lot of, let's say, handcrafted methods, but now that there is an API, for instance, for ADMEYT predictor for this module, now that we have APIs for the other parts of our pipeline, then it's easier for us to deploy it. And yeah, there are things that we didn't know. Like, for instance, just to give an example, remember that when we were talking about PK profiles, like predicting a single PK profile, we didn't realize how many data points there were output there. And so many that actually just for running 1,000 compounds, then we ended up without memory in our servers because we didn't realize that. So we had to actually come up with a solution in collaboration with you guys of how to, let's say, trim those profiles and still get the information we wanted. But once the system is there, then it's also a second element that for us is very important, which was the kind of like the change management, because not because the tool is there means that people are going to use it. So that also leads to a lot of work from our team, particularly the team that is actively training people and making sure that the people are up to date on this technology. This is where we see it's not just about deploying tools or providing people with the tools, but it's also helping them to understand them and to use them in their daily work. And now we have seen the kind of like the rewards of that projects move up, they make better decisions. But it's not something that will come immediately, right?
Yeah, indeed. Well, thank you for this perspective. I mean, indeed, I mean, it's just going through several stages. I mean, I think you described some of this in your paper, that the validation work that went on to establish results in GastroPlus first, reproducing these results in the high throughput PK setup, and then using another platform to deploy this. And as you described, the change management as well to make sure that these technologies are being deployed to end user desktops, so they can make a pretty common use, in the end, fairly common use of these tools. So yeah, it's pretty big change, but it's pretty exciting at the same time. Well, thank you. I mean, are there other examples that anyone would like to share in terms of deployment strategies for their technology, in terms of making it more accessible to end users, easier to integrate into end user workflows, and things of that nature? Because again, I think the ease, it's not just the ease of use, it's also the ease of deployability, the scalability, and all these aspects that in the end make those tools be used and deployed by our clients.
I think some people can be hesitant to use these tools because they view them as a black box and they just don't understand them. So I think one of the most powerful things, at least from a technical standpoint, is to educate them on what's behind the scenes and really pick out the components, let's say, of GastroPlus that are being used, really educating on what inputs are needed, how is the software working, and then what are the outputs, and then really just the expectations around those outputs. I think people are hesitant to rely on those tools when they can generate in vitro data that they feel like is truth, even if it's not representative of in vivo, where in silico tools can be a black box that they don't understand, and they're hesitant to make decisions based off them.
Yeah. And I mean, I know that in the ADMEYT predictor documentation, for example, I mean, we disclose a pretty significant amount of detail of everything. I mean, well, the data sets certainly that go into the model construction, and the internal statistics of the model construction, and on the training set, on the test set, etc. So there's building probably a certain expectation of the model performance, but I think it's important to have that level of transparency that well, if the prediction is going to be within twofold, should be within twofold, then well, that's what it is. And if it's going to be more like within threefold, then that's what it is. But at least you can get sort of a sense from the published information that that's sort of what what should be expected.
Yeah, and I find all that information in the user manuals in ADMEYT Predictor and GastroPlus to be extremely helpful. And I was speaking more in terms of the people who aren't actively using the software, but the people that someone like myself is presenting to. And so it's like distilling down the right level of detail to them to help them build confidence and using those predictions, I think is the trickier part.
Great.
So,
Right.
yeah.
Go ahead.
No, go ahead, Robert.
No, you go ahead. I've been talking too much.
Well, one of the things we run into with on the QST side is just how much extra complexity there is in terms of crossing the line between the people who built the model and therefore kind of know what levers to pull. And we've been using the model for some of us have been using it for 12 years now. So, and then anytime another potential user, potential client comes along, they're climbing that learning curve. And so just the necessity of having large training events and lots of training videos and lots of things, the materials that people can go back to, even beyond a user manual. There's only so much you can learn from just reading a user manual, and they're just kind of being there to answer all of the questions that are inevitably going to come up. Hey, I pushed this button and it's I ran this simulation, nothing happened. Why is that? Oh, well, there's a parameter that if you don't flip it this certain way, it because these things that we're used to thinking about, but maybe you don't see as being potential stumbling blocks until someone tries to actually use it and stumbles over it. So just kind of constantly being engaged with people who want to climb that learning curve and want to start adopting your technology is important in a lot of ways.
Yeah, and I think I'll piggyback off of Jeff and say, you know, during the so on the QSP side, I think we've got, you know, some difference. Well, we've got kind of a joint connection between like the use of the models and the development of the models, and certainly on the development side, there's kind of a relationship between an industry partner that's interested in that development, supporting that development, and so, you know, maybe not so much training as ongoing discussion about, you know, what we're doing, how we're building the model. You know, for ILD in particular, we had I think every other week meetings where we were kind of demonstrating the software during development. That's maybe one extreme, but that's an example of where we were kind of building that training in while we were making the platform. But then, you know, there's constant training development in terms of, you know, how do we convey what's in the platforms in a way that's digestible to somebody who's going to use the software. And so that's something we're always revising and then kind of tweaking depending on the needs of somebody who's interested in what we're using. And then there's a lot of back and forth in terms of somebody digs into the software and then has particular questions and needs more information in this area. Their target hits this part of the pathophysiology, and so there's a lot of dynamism in terms of, you know, we can't just develop a training set. We've got to kind of be flexible to build out what might be a targeted need for every user. So it's sort of interesting in that aspect, general versus targeted training, that we kind of have ongoing development in this sort of QSP world.
Go ahead.
Okay, let me offer a technical perspective, but it will be biased. Okay, it will be about large pharmaceutical companies with potentially hundreds or even thousands of users, and deployment of ADMEYT predictor in those companies. So first of all, they use their own internal software workflows. They don't run programs individually on their Windows laptops. No, not at all. They have a company-wide workflow, for example, hosted by Pipeline Pilot or some internally developed proprietary platform, and they run all the software through that lens. That's one. Number two, in order to avoid tyranny of their IT departments, they don't run this platform on Windows, they run it on Linux. It's been happening quite a bit, and I've seen quite a number of companies doing that. Fortunately, we do have a Linux version of ADMEYT Predictor, as well as well-developed a command line and so-called REST API interface. But that presents quite a number of significant challenges, like certain features available in Windows but not available in Linux, and that we're working on that to improve it. And I wonder if our users are feeling the same way and can add more point to what I said. Anyone?
I don't.
Yes, I think that very few people in the DMPK departments have Linux. So then it's up to either a computational chemist or someone else, and they are not always up to date with the biology and the science there. So yeah, and I know that when trying to introduce ADMEYT predictor data to the chemists, at least in the beginning, they were very suspicious for two reasons. That all the data sets in the manual or on the homepage were from big pharma data sets that they thought could be sort of, well, filtered to fit the model. And the other thing was that if you built a local model, for instance, I mean, it worked for a while, but then since you sort of left the chemical space where you built the model, it didn't work anymore. And then they said, this is just so. You had to build it again and again and again and show that when including other functional groups, it actually works again. But it's a bit of a pedagogic problem.
Let me comment on that, because you raised a very important issue, and I'm offering a few solutions to that problem. First of all, this is actually the best approach to build a local model. But the local model is good locally, right?
Yeah.
It's usually built with small number of compounds, and it doesn't represent much of the chemical space. So there are a few ways to improve it. You can add, let me just use S+ or log D as an example, okay? You presented today the advantage of local log D model versus S+ log D. So first of all, okay, you can use S+ log D as a descriptor in your local model. Okay, and that way you incorporate a little bit of the, or you inject a little bit of wider chemical space to your local model. Okay. There's a better approach. ADMEYT modeler offers so-called delta models, where you base your local model on S+ log D and model a difference between experiment and the predictions. And that is a better approach, so slightly better than just using log D as a descriptor. But the best approach, and I encourage you to do that, is to share your data with us. We would append data to our data set and build a model that covers the widest chemical space and has a best representation of all the interactions and so on. Yeah.
And we work hard in getting companies to share with us, and the recent companies we've worked with are huge ones, and so we're convincing ourselves that if they have worked with us, then others will too, because they're one of the biggest companies out there. So if they feel that it's that it is secure for that data, so certainly other companies shouldn't have any reservations. So
but apart from that, there's still first two methods to improve your model, and I encourage you to try them.
Sure.
But now,
actually,
Robert,
go ahead. Actually, I thought that the global log D model is very good, and the improvement by making a local model wasn't that big. We did improve slightly, but I mean, it was good enough before. And I think that is because that's more or less just a chemical model. There's no biology in that. And once you start working with hepatocytes or microsomes, etc., it depends on the actual batch you use and the characteristics of that, and also the assay system, because you can use very different